Hey everyone, today we're going to start with our first lesson on dividing fractions. We touched on this a little bit in our spiral, so hopefully it's not totally new to everyone. The first thing we need to think about when dividing fractions is knowing what the word reciprocal means. So a reciprocal is when you're dealing with a whole number or fraction and you flip the numerator and denominator. So you're going to write things as we go. A reciprocal is when you flip the numerator and denominator. So I have a spot for an example here. Please pause if you aren't keeping up and make sure you have everything written down, okay? I have an example here. So say, for example, I have the fraction 2/7. I know that the reciprocal of 2/7 would be 7/2. So that is your reciprocal. That is when you flip the numerator and the denominator. So the 7 became the numerator and the 2 became the denominator. The only tricky part about reciprocals, if we add another example right here, is if you have like a whole number. So say we're looking at the number 9. You have to remember that 9 is the same as 9/1. So the reciprocal would be 1/9. Okay? Now, the next question says what happens when you multiply a fraction and a reciprocal. So let's do that. Let's look at the one we have up top. If I have 2/7, that's the fraction, and I multiply it by the reciprocal, okay? When you look at that, 7/2, we know we can simplify when we multiply fractions vertically, diagonally, never horizontally, right? So if I look at my diagonals on a reciprocal, they're always going to be the same because you just flipped it around. So you know that 7 and 7 are going to cancel out and make 1 and 1. And 2 and 2 are going to cancel out and make 1 and 1. And when you multiply across, you get 1/1, which is 1. And that happens every time you multiply a fraction by its reciprocal. It always gives you 1. So it always has a product of 1. So when you're dividing fractions, then what do? Like, why are we learning this word reciprocal? So let's think about it. You don't ever actually divide fractions. When you are working with division and fractions, you're going to change it to a multiplication problem every single time. So what are we going to do? We are going to multiply by the reciprocal. That is what you do to divide fractions. Multiply by the reciprocal. There is simplifying in division, but it's only after you've changed it to multiplication. So let me say that again. There really isn't simplifying in division. The only time you can simplify vertically and diagonally is when you have a multiplication problem. So you cannot simplify until you have changed it to a multiplication problem, okay? That is the only time you can simplify vertically and diagonally. So here's my first example. If I give you 3/4 divided by 2/7, okay, that's a division problem. Now, even though 2 and 4 can be simplified, we can't do it right now. The only time you can do it is when it's changed to a multiplication problem. So the 3/4 stays 3/4. You write it exactly the same as it is. Division becomes multiplication, like it says, multiply. And then you take the reciprocal of 2/7, and it is 7/2. Now we look to see if there's anything that can be simplified, now that it's a multiplication problem. 4 and 7 cannot be simplified. 3 and 2 cannot be simplified. 3 and 4 cannot be simplified. And 7 and 2 cannot be simplified. So I'm going to multiply across. 3 times 7 is 21. And 4 times 2 is 8. And if everything was simplified here, the only thing you should ever have to do at this point is change an improper fraction to a mixed number, which you will have to do. 21 divided by 8. 8 goes into 21 2 times. That's 16. Subtract, you get 5. So my mixed number is 2 because it's 2 whole times, and 5/8 because there is 5 left over and you're dividing them into eighths. So 2 and 5/8 is the answer. So that is how many times 2/7 goes into 3/4. All right, let's do another one. If I give you 15/6 divided by 9/22. Okay, and again, don't be tempted to simplify the 6 and the 9. Remember, you have to change it first. So go ahead and try that. And then you'll choose your answer in the choices, and then we'll do the problem after. Okay, so we had 15/6. Division becomes multiplication. And 9/22 becomes 22/9. If I have 6 and 22, I look at that and I see that they're both even. Since they're both even, I know that 2 goes into 6 3 times, and 2 goes into 22 11 times. I look at 15 and 9, and I think sometimes people miss these. Sometimes people miss the ones with the 3s, but 3 does go into both 15 and 9. 3 goes into 15 5 times. 3 goes into 9 3 times. I check my verticals, 5 and 3, nothing. 11 and 3, nothing. So I'm going to multiply across. 15 times 11, 5 times 11 is 55. And 3 times 3 is 9. I notice it's an improper fraction. So I'm going to do 55 divided by 9. 9 goes into 55 6 times. That is 54. Subtract, I get 1. So I see that it is 6 whole times with 1 left over out of the 9, the size of the pieces we're doing, ninths. So the answer is 6 and 1/9. Okay, let's keep going. We have example 4. For example 4, we are doing 6/8 divided by 9/20. Try that out. Okay, so I have 6/8 divided by 9/20. I can change that. The first fraction never changes, so it stays 6/8. Division becomes multiplication, and 9/20 is 20/9. We're going to check our diagonals. I have 8 and 20. Does anything go into 8 and 20? We know that 2 does, but also 4 does. So if I divide by 4, 4 goes into 8 2 times. 4 goes into 25 times. 5 and 2 are done. I look at 6 and 9. I know that 3 goes into both of those. 3 goes into 6 2 times. 3 goes into 9 3 times. And here is where some people get confused. And this is why I wrote this down here. Always make sure your answers are completely reduced. Sometimes people forget to check the verticals. So if you look here, I have this vertical. It's 2/2. That can simplify to 1 and 1. If I don't do that now, you're going to end up with a fraction later that's not completely simplified. So you have to make sure that you're checking both diagonally and vertically. So 2 goes into 2 one time, like I said. 2 goes into 2 one time. When I multiply across, I get 1 times 5, which is 5, I'm sorry, checking 5 and 3, there's nothing there. Check in my head sometimes and don't say it out loud. And 1 times 3 is 3, so I have 5/3. If you didn't simplify here, this would have been 10/6 if you didn't simplify. And then you would have had to reduce that 10/6 to 5/3. So I know that 3 goes into 5 one whole time. I know that there is 2 left over out of the 3 that we are dividing by. So 1 2/3. So that's why always make sure. And then if it's improper, make sure it's reduced. Okay, last one, complex fractions. People get confused by these because they're unsure of why it looks the way that it looks. So if you notice, we know that fractions are division problems. So if I look at this problem here, this is really just a huge fraction. And we have a fraction divided by a fraction. It's just like the other problems. We call this a complex fraction when the numerator and denominator contain a fraction. So a complex fraction, just to say it better, is when the numerator denominator or both contain a fraction. And like I said in this one, they both do. This is 2/3. Here's my fraction bar. And divided by 4/5. So you can rewrite this as 2/3, my numerator, divided by 4/5, because fractions are division problems. And then once you've rewritten it, then you can follow the steps. So 2/3 stays 2/3. Division becomes multiplication. And 4/5, the reciprocal is 5/4. Check my diagonals, 3 and 5. Nothing. 2 and 4, yes. 2 goes into 2 once. 2 goes into 4 twice. 1 and 3, nothing. 5 and 2, nothing. So when I multiply across, I have 1 times 5, which is 5. And 3 times 2, which is 6. And neither of these, this is not improper, and it can't be reduced anymore. So the answer is 5/6. Okay, so you're going to practice this on your own. Good luck. I know you're going to do great.